For decades, assessing student knowledge was a physical process. Rows of desks, ticking clocks, and watchful invigilators ensured that the work submitted was genuinely human. Today, that physical environment has been bypassed by a borderless digital ecosystem where technological assistance is just a click away. This chart shows how quickly generative AI has integrated into student workflows, according to data from HEPI and Cortex. In a single year, the percentage of UK undergraduates using these tools surged to 88%. In this environment, students are deploying AI agents, software designed to plan, search, and execute multi-step tasks without human intervention at every turn. Unlike a simple chatbot, an agent sets its own sub-goals to achieve a long-term objective. Universities have responded by purchasing commercial AI detection software. Administrators use these scanners to police the boundary of human authorship, checking every submission for statistical fingerprints. This dynamic forces educators into the role of forensic digital police. Institutions are locked in a technological arms race, trying to outcompute the very tools that define the modern workplace. From the student's perspective, generative AI often looks like an advanced tutor. They use these systems to refine their grammar or organize complex notes into a logical structure, viewing it as a standard part of their study routine. However, institutional policies frequently classify this as unauthorized content generation, or UCG. This term covers the unacknowledged use of AI to produce any part of an assignment, effectively equating a grammar check with hiring a ghostwriter. This diagram plots the overlap between what students consider fair use and what universities classify as misconduct. As the circles show, there is almost no shared ground. In this gap, students believe they are working legitimately, while automated filters flag that same work as contract cheating. The fallout appears on social media platforms like Reddit, where students share narratives of confusion after being flagged for using tools they believed were permitted. This misalignment turns a moment of technological evolution into a series of high-stakes disciplinary hearings. To understand why these hearings are frequent, we must look at the math behind detection software. These tools typically rely on two core metrics, perplexity and burstiness. This visualization demonstrates perplexity, measuring how predictable a word sequence is. LLMs select the most probable next token, outputting low perplexity. Burstiness refers to variation in sentence length. Human writing is naturally bursty, whereas machine text follows a monotonous rhythm that software recognizes. In response, a secondary market has emerged for AI humanizer agents. These are tools specifically designed to dismantle those two metrics. A humanizer agent systematically injects erratic sentence lengths and uncommon vocabulary into synthetic text. It effectively mimics the noise of human writing. By scrambling these statistical signatures, the text can bypass commercial scanners without detection. This creates an incentive for students to actively degrade their work's readability to pass automated filters. The current technology rewards sophisticated deception while failing to measure whether any actual learning has occurred. While these algorithms fail to catch sophisticated cheaters, they produce a specific type of error that targets a particular demographic of genuine students. A landmark study from Stanford University highlighted the inequity built into these tools. This chart compares false positive rates from the Stanford study. For essays by native English-speaking US 8th graders, detectors showed only a 5.1% error rate. But for TOEFL essays by non-native English speakers, they falsely labeled 61.3% of human work as AI-generated. This happens because non-native speakers often rely on safer, standard vocabulary to avoid grammatical mistakes. The algorithm evaluates this linguistic caution and simplicity, interpreting it as the signature of a machine. This leads to the investigation trap, where an instructor initiates a disciplinary hearing based entirely on a high but flawed percentage score. The accused student is then forced to prove a negative. They must provide evidence of their own thoughts against an opaque algorithmic black box. For international students, false flags jeopardize scholarships, academic standing, and student visas, leading to severe anxiety. Using statistical forensics to govern academic integrity creates structural inequity, undermining trust between student and teacher. Because surveillance is easily bypassed and demonstrably biased, the viable path forward is to redesign assessments to make cheating more difficult to outsource. This graphic outlines the traffic light AI framework to eliminate ambiguity. It marks red zones where no AI is allowed, amber for ideation, and green for co-creation. These explicit guardrails ensure students know exactly where AI agents are permitted, significantly reducing accidental misconduct. Another solution is shifting to process-based grading. Instead of grading only a final submission, instructors evaluate a portfolio of work. This portfolio might include early drafts, AI prompt histories, and personal reflections. It makes the student's research journey as visible as their conclusion. When we evaluate the thinking process rather than just the final product, we reclaim the value of human intellectual effort. To completely bypass the inherent limitations of detection software, some departments are now returning to direct, face-to-face academic dialogue. Short oral defenses, viva voces, or interactive in-class presentations provide proof of a student's comprehension that AI cannot mimic. This approach has trade-offs. It requires significant timetable reorganization and more upfront labor from faculty who are already managing heavy workloads. This quadrant chart maps pedagogical choices, plotting authenticity against educator effort. Process grading and oral vivas sit in the high-integrity quadrant. They contrast sharply with unproctored online exams, which are easy to grade but offer almost no defense in an AI-saturated environment. By moving past the attempt to police AI through algorithms, educators can build a curriculum that prioritizes genuine learning over the illusion of control.